Okay, I'll advise that you pause this video, try to attempt this problem, and put your answer in the comment section. Yeah, I just want you to be able to identify the tricky aspect of the problem. Okay, let's start. A mass m1 collides with a stationary mass m2. So we have m1 to be equal to 0.4 gram. Then u1, we don't know u1. We have another mass m2 which is 1.6 gram. The initial mass is 0 because it is stationary. Okay, assume that the collision is perfectly elastic. If m2 moves with a velocity of this, so after the collision the v2 is 4.4, where v2 is the final velocity of mass m2 and u2 is the initial velocity of mass m2. Okay, so v1, which is the final velocity of mass m1, is unknown. So we have, okay, after the collision and m1 is scattered at 50 degrees. Okay, let's have the diagram. Let this be mass m1 which collides with another mass m2. Suppose that this broken line is their initial position. So we assume that m1 is being scattered towards this side, so that m1 v1, that's the momentum, and then we have this for m2 v2. Let's call this beta and let's call this alpha. But note that in the question m2 is greater than m1, which implies that after the collision the smaller mass, which is m1, it will move backwards. The direction will be backwards. It will move backwards. Now it implies that m1, which has the smaller mass, is being said to be scattered. m1 is scattered at 50 degrees from its original position. That means this 50 degree is towards the back, is backwards. So it means that I have 50 degrees here. So the remaining angle of alpha is 180 minus 50 degrees, which is 130 degrees. Alright, so I have alpha as 130 degrees. I don't know beta, so we have three unknown. The unknown, we have u1, we have v1, and then we have beta, and that's what they ask us to find. Calculate the initial and final velocities and then the direction. So all right, now to furthermore, a kinetic energy will be conserved. This is the initial scenario of the collision, and this is the final scenario of the collision. Since momentum is a vector quantity, and in this kind of collision, which is a collision in two directions, the momentum is in two directions. It has components in the y-axis and it has components in the x-axis. So we will need to resolve. Yeah, if you don't know how to resolve vectors, you can check the videos that is being suggested up here. Alright, now we will need to resolve. Let's consider the x-axis at first. Now before the collision, this is before the collision. Before the collision, the masses, they have nothing to do with the y-axis, so they are only on the x-axis. They are along the x-axis. So we can say that for x, we can say m1 u1, that is their momentum. We don't know u1, but we know u2. u2 is equal to 0, so plus m2 u2. But because u2 is 0, then that term will become 0. So I don't need to write plus 0 since it is 0. So I can just go ahead and say equal to. I'll consider this place now. For the first body, I will need to resolve m1 v1. I will need to resolve it to the x-axis. If I resolve it to the x-axis, if I resolve m1 v1 to the x-axis, because there is an angle here, in that video that I ask you to watch, you will understand what I mean. Because there is an angle here, I will have it as m1 v1 cos alpha plus, I will resolve this to this place as well, to the positive x-axis, so that I will have m2 v2 cos beta. So the same thing happens for the y-axis here. Yeah, on this place, for the y-axis here, the masses before the solution, they have nothing to do on the y-axis. So that's 0 plus 0, which will be equal to, and then I will resolve this to the y-axis. So this is the y-axis, a normal. That's going to be a normal. If I resolve it to that normal and it's positive, I will have m1 v1 sine alpha. Then if I resolve this to this place, and don't forget this is the negative y-axis, if I resolve it, I will have minus m2 v2 sine beta. Now, but I have 3 unknown, so these 2 equations will not be able to help me. We need 3 equations to solve 3 unknown. So, but recall that the collision is perfectly elastic. It means energy is conserved, and if energy is conserved in a collision, it means that after the collisions, the 2 bodies, the 2 objects, they possess kinetic energy to be able to move in their separate ways. That means after the collision, mass A can move with its own velocity, we can call it v1, or mass 2 can move in its own velocity. They can move in different direction, or as the case may be. So we can say that kinetic energy before the collision is equal to kinetic energy after the collision, since kinetic energy is conserved, it's not lost. So we can say half m1 u1 squared. Actually, formula for kinetic energy is half mv squared, but since we are considering mass m1 and velocity u1, so we change it. Now the second body should be half m2 u2 squared, but because u2 is equal to 0, so I will just need to neglect that place, so that then I'll have equal to, for the second body, don't forget that kinetic energy is a scalar quantity. It has nothing to do with the direction. So I'll just go ahead and write half m1 v1 squared plus half m2 v2 squared. So that's these are the 3 equations. Let's call this equation 1. Let's call this equation 2, and then let's call this equation 3. Now, ability to solve this equation correctly will give us the answer to u1, v1, and beta. So there are several methods to solve these 3 equations correctly. So I'll be using one of the simplest methods to explain it, so that we can obtain the answers for the initial, final, and beta. Okay? From equation 2, in equation 2 we have 0, which is equal to m1 v1 sine alpha minus m2 v2 sine beta. That m2 v2 sine beta, which will be equal to m1 v1 sine alpha. That is, I have added minus m2 v2 sine beta to both sides of the equation, or you can say that I have taken this to the other side. Now I can say that sine beta sine beta is equal to m1 v1 sine alpha upon m2 v2. That is, I divided both sides by m2 v2 m2 v2, so you obtain this. Now from equation 1, okay, let me do that here. From equation 1, don't forget equation 1 is m1 u1, which is equals to m1 v1 cos alpha plus m2 v2 cos beta. So we can say that we want to make cos beta the subject of the formula. So it implies that m1 u1 minus m1 v1 cos alpha is equal to m2 v2 cos beta. So if I divide both sides by m2 v2, I'm dividing both sides by m2 v2, and we have it like this, so that cos beta will be equal to m1 u1 minus m1 v1 cos alpha all over m2 v2. But note that I can still simplify the numerator so that I will have something of this nature, so that my cos beta will be equal to m1 then u1 minus v1 cos alpha all over m2 v2. So recall that sine squared alpha, sine squared beta, okay, recall that sine squared beta plus cos squared beta is equal to 1. So I can write this, insert it here, take this, insert it here. So sine squared theta is now m1 v1 then sine alpha plus cos square, which is m1 u1 minus v1 cos alpha all over m2 v2. They are all equal to 1, so I just have to square this. Okay, now if I square that, I should have m1 v1 m1 squared v1 squared sine squared alpha upon squared u1 minus v1 cos alpha squared over m. So the expression here is just like having ab all squared. AB all squared will give us a squared b squared according to law of indices. So it's the same thing that we have m1 squared, then the others in brackets also has their own squared. So what I will do next is to find the LCM. If you find the LCM, you will obtain something of this nature: m1 squared v1 squared sine squared alpha plus m1 squared into u1 minus v1 cos alpha all squared all over m2 squared v2 squared, and that's supposed to be equal to 1, so that I will eventually have m1 squared v1 squared sine squared alpha plus m1 squared u1 minus v1 cos alpha all squared. So have it equal to m2 squared v2 squared. So it's just like I multiply both sides by m2 v2 by m2 squared v2 squared, so that I obtain this. Now we can continue further since m1 is common to both sides. So we can say m1 into v1 squared sine squared alpha plus u1 minus v1 cos alpha squared, which is equal to m2 squared v2 squared, so that we can eventually say that v1 squared sine squared alpha plus u1, okay, I gotta erase that. So plus u1 minus v1 cos alpha squared, which is equals to m2 squared over m1 squared v2 squared. So I can rewrite it as m2 over m1 all squared then v2 squared. To furthermore, we can try to expand this expression. If you expand this expression, v1 squared sine squared alpha plus, if we expand the expression that I underlined as red, you will have u1 squared then plus v1 squared cos squared alpha minus 2u1 v1 cos alpha, which is equal to m2 over m1 all squared then v2 squared. So but don't forget that this and this, they are common, because I can bring out v1 squared and say that sine squared alpha plus cos squared alpha, yeah, that expression is this. Yes, because sine squared alpha plus cos squared alpha is equal to 1. So I will eventually have something of this nature. So I will eventually have v1 squared. So this and this has become v1 squared. Then I'll have u1 squared. Also, I'll have minus 2u1 v1 cos alpha, which is equals to m2 over m1 m2 over m1, then we have squared, then we have v2 squared. Now we can simplify it further, but recall that v1 plus u1 all squared is equal to v1 squared plus u1 squared plus 2v1 u1. So I can say that v1 plus u1 all squared minus 2v1 u1, which is equals to u2 u1 squared plus v1 squared. So it implies that anywhere I see u1 squared plus v1 squared, I will just substitute it with this. So instead of having this in this equation, I will have this. Now, so instead of having v1 squared plus u1 squared, I'll have this v1 plus u1 squared minus 2u1 v1 then minus u1 v1 cos alpha, which is equal to m2 over m1 then squared v2 squared. So minus 2 u1 v1 is common to both sides, so that we can have v1 plus u1 squared. Don't be tempted to say that minus 2 u1 and minus u1 v1 cos alpha. Don't be tempted to say it is equal to minus 3 u1 v1. No, no, no. So that's bad in algebra. So we are going to have 1 plus cos alpha, which is equal to m2 over m1 squared, then v2 squared. So as a result, I think we should pause. Okay, we can call this, let's call this equation 5. Now let's continue from 3. We have just simplified that equation to its least. From 3, remember that 3 is half m1 u1, which is equal to half m1 v1 squared plus half m2 v2 squared. So I can bring m1 v1 to the other side, so that I will have m1 u1 minus m1 v1 squared, so that will be equal to half m2 v2 squared. So my half is common to both sides. m1 is also common to that term, so we can have u1 minus v1 whole squared is here, so we can have u1 squared minus, okay, let me erase that, so to half m2 v2. So we can divide both sides by the half, so that we can obtain something that looks like this: m1 u1 squared minus v1 squared, which is equals to m2 v2. So we can see u1 squared minus v1 squared is equal to m2 upon m1, just like the other time, then v2 squared, squared, yeah, don't forget this square. So m2 over m1, then v2 squared. So it looks like we may not be able to simplify further because of u1 squared minus v1 squared, but there is a way out, because we need to break it down. If I square both sides, I will have u1 squared minus v1 squared. Just squared both sides, and that will be equal to m2 over m1, then v2 squared, all squared. So I will have something of this nature, all squared. Okay, so if they are all squared, it means that I will have m2 over m1 having its own square, then square is already on v2, so it becomes raised to power 4. So we have this from the last screen. We have u1 squared minus v1 squared, all squared, which is equal to m2 upon m1 squared, then v2 raised to power 4. Now note that this is difference of two squares, and if it's a difference of two squares, I can say that u1 plus v1, then u1 minus v1, then all square. Yeah, the reason is because u1 minus v1, difference of two squares, the difference between two things that are squared will be u1 minus v1, then u1 plus v1. So that's equal to m2 upon m1 squared, then v2 raised to power 4. So note that if two things are inside the bracket and they are all squared, something like this, it will become p squared and q squared. So the difference of two square will take each will take square, so that I will have u1 plus v1 squared, then I will have u1 minus v1 squared, which is equal to m2 upon m1 squared, then v2 raised to power 4. Note that I already have an expression for u1 plus v1 in equation 5, so I'm pleased with this, but u1 minus v1, I'm not that pleased with it because it's like a stranger. So we need to find a way to simplify it. If I expand this bracket, I will have something of this nature: u1 plus v1 squared. If I expand this, I will have u1 squared, okay, plus v1 squared minus 2u1 v1, which is equal to m2 upon m1 square it, then v2 raised to power 4. But note that u1 squared plus v1 squared is the same thing as u1 plus v1 squared minus 2u1 v1. The reason is because u1 plus v1 all squared, if you expand it, it will give you u1 squared plus v1 squared plus 2u1 v1. So if I take this to the other side, it will become u1 minus plus squared, then minus 2u1 v1, which is equals to u1 squared plus v1 squared. It means that anywhere I see this u1 squared plus v1 squared, I'll substitute it with this. So anywhere I see it, I need to substitute it so that it becomes u1 plus v1 squared. Then I will have what I want to substitute, which is open bracket u1 plus v1 squared minus 2u1 v1. That's that. Then don't forget the remaining one, which is minus 2u1 v1. Then close the bracket, which is m2 upon m1, then v2. Don't forget that everything is squared, then v2 is raised to power 4. So we can simplify this further so that it will become minus 4 u1 v1. Okay, so don't forget that this is what we had on the former u1 plus v1 all squared, then open bracket u1 plus v1 another bracket, then minus 4 u1 v1, which is equal to m2 upon m1 all squared, then v2 raised to power 4. Yeah, so this is also an expression that is similar to that of equation 5. So let's call this equation 6. Now in equation 5 and 6, let it be equal to u1 plus v1. We want to simplify further, and let q be equal to uv, so that anywhere I see, so that equation 5, don't forget equation 5 will become 5 will become 5 will now become p squared minus 2q open 1 plus cos alpha, which is equal to m2 over m1 squared, and then v1 squared. That's equation 5. So I can make p squared the subject of the formula, so that I will have something of this nature: m2 upon m1 squared v1 squared plus 2q open bracket 1 plus cos alpha. So that's p squared. Now 6 will become, I'll have p here, so that it becomes p squared, then another p squared minus 4q, which is equal to m2 over m1, then I have squared, then v2 raised to power 4. So that we can call this, let's call p equation star. We can expand this so that it becomes p square minus 4q p squared, which is equal to m2 over m1 squared, then v2 raised to power 4. So if we substitute p squared into this equation, let's call it equation star star. Let's call this equation star star. So what we are going to do now is to substitute star into star star. If we put star, which is p squared, if I put it here, I'll put it here, then we'll simplify the equation. We are almost done. So if I substitute p square into that equation, if I substitute p square into equation star star, I'll have something of this nature: m2 over m1 squared, then v2 squared plus 2q open a bracket 1 plus cos alpha, then all squared. Since we had p squared then square, so don't forget, then we have minus 4q, then p squared again, so our p squared is m2 over m1, this as a squared, then v1 squared, then plus 2q open a bracket 1 plus cos alpha, then square it. So that's it. It has to be equal to m2 upon m1 squared, then v2 raised to power 4. So if we continue, if we don't forget that alpha is 30 degrees, 130 degrees, and then m2 is 1.6, m1 is 0.4. So which other thing do we have? v2 is 4.4. If we substitute it into this equation, so since alpha is 130, so we can find cos alpha. That's cos 130 degrees. So if we do that, cos 130 degrees minus 0.627, then 1 plus answer, which is 0.357, then we multiply it by 2, the 2 that is behind q. If we multiply it by 2, then we should have 0.717. So and then if you divide m2 by m1, that should give you 4. 4 squared, that is 16. Then v2 is 4.4. If you multiply 16 by 4.4 squared, you should obtain, if you multiply 16 by 4.4 squared, you should have 309.76. So that it will become 309.76 plus q, open it, then 0.7144, then put the square, then minus 4q, then our p square again, so we are going to have 309.76 plus 0.7144q. So if we do that, it has to be equal to this as well. If you square, m2 is 0 or is 1.6, m1 is 0.4. If you divide it, you will have 4. 4 squared, that's 16. 16 times 4.4 raised to power 4, that will give you 5996.9536. So we are very close to a quadratic equation. So I will need to expand by multiplying both sides by 4, and then I will need to expand this expression with squared. If you expand it, you will have something of this nature: 95951.2576 plus 0.51 q squared, yeah, plus 442.5850884, then minus this, minus, we now want to multiply minus 4 times this. Should have a q, this should have q, okay, that should have a q, then minus 4 multiplied by this will give us minus, that's minus 1239.04q, then minus 2.8576, then q squared, then minus 5996.9536, which is equal to 0. So minus 4 times this should give you this, minus 4 times this should give you this, minus 4q times 0.71144q will surely give you this squared. So don't forget, this is the minus. So, and it's supposed to be equal to this. So I took this to this side so that we can have a quadratic equation. So if you take this to this side, it becomes negative. We need to add this and this together, since they are the constants in the equation, and then we need to add this and this. Don't forget that this is a negative value, so that means this minus this. So if you simplify this equation, you will arrive at minus 2.3. So if you solve this quadratic equation on your calculator, you will obtain 89.39 and a negative value. So we will meet the negative value. So since this is our q now, so we can find our p. Don't forget that we had an equation for p. squared is m2 upon m1 squared v2 squared plus 2q into 1 plus cos alpha. So we already simplified all of this. You know cos alpha, 1 plus cos alpha multiplied by 2. We know q now. So if you insert all of those, you will have 309.76 plus q, and then open bracket 0.7144. So you have something of this nature. So our q, which is 89.39, if we substitute it, it will become 89. P is the square root of 373.620216, which is equal to 19.33. But recall that u1 plus v1 is equal to 19.33, and then u1 v1 is equal to q, and our q is 89.39. So don't forget, we can now infer from this place straight up that v1, or we can even use any value, we can use u, but let's go with v1, which is 89.39 upon u1. So I just made v1 subject. If this is v1, then if I put it in this equation, I will have u1 plus 89.39 over u1. That will be equal to 19.33. So if I find the LCM in this case, I will have u1 squared plus 89.39 all over u1, and that's supposed to be equal to 19.33. So that I will have a quadratic equation, which is u1 squared plus 89.39, and that's going to be equal to 19.33 u1. So I will need to take this to this side so that I will obtain u1 squared plus 89.39. I'll rearrange it immediately. If I take 19.33 u1 to the left hand side, I will have minus 19.33 u1 plus 89.39, which is equal to 0. So if I solve this quadratic equation again, if you solve this quadratic equation, you will obtain u1 to be equal to 11.67 meter per second. So that's our u1. So we can get our v. Don't forget that v, u1 plus v1 is equal to 19.33. So it means that v1 will be 19.33 minus u1, which is 11.67. If you do that correctly, you should have 7.66 or 7.65 meter per second. So we have obtained u1 and v1. In order to obtain the angle, which is angle beta, we are going to recall that sine beta is equal to m1 v1 sine alpha over m2 v2. So it means that beta is the arc sine of m1 v1 sine alpha over m2 v2. If you insert all of those values in this place and you find the arc sine, you will arrive at the answer, which is 19.45 degrees. But let's do it. So beta is the arc sine of 0.4, which is m1, multiplied by v1. v1 is 7.66. We have just obtained it. Then sine alpha is sine 130 degrees, all over m2, which is 1.6. m2 is 1.6, so multiplied by 4.4, so that will give us the arc sine of 0.3333. And if you do that, you will have 19.45 degrees. So that's the answer. I hope this was what you got in the first time I asked you to calculate it. If this is not the answer, so try to go through the video without skipping any part of the video. So the question is simple, but it requires that you calculate the three unknown from the three equations. Alright, so do subscribe to this channel, share these videos with your friends. Okay.